Hi everyone and welcome to the new video. My name is Dimitri and I work as embedded software developer. In the previous tutorial we used the LED on a Raspberry Pi, and today I will show more fun stuff. In this tutorial I will show how to use addressable LED. It's much more fun because it can show RGB colors, it can be used as a LED strip or as a matrix. As the first example I will show how to display a scrollable text on the matrix, and as the second example we will make a small game. It will be fun and let's see how it works. If you are first time on this channel, I recommend to see the first video, because in that video I explained how to use a Raspberry Pi, how to use the terminal, how to synchronize the files, because we're working with the hardware and our code will be executed on the Raspberry Pi, so you should be comfortable with that. And now let's get started. First we start with the hardware, and because we are using addressable LEDs we need to figure out how it works and we need to know how it works. When we are dealing with a new hardware, the first step is usually to open the datasheet and to see what specifications we have. For these LEDs we can easily find the documentation online, and what is important for us is to get the pin out. As I promised at the beginning, no soldering is required for our project, but it is important to understand how things works because we will need to code these LEDs in our Python. So this is a single LED, and as we can see it has a ground, it has a power, and we have two pins, data input and data output. So first these LEDs are connected in a cascade one to another, first to second, pixel 1, pixel 2, pixel 3, and the logical idea behind is very useful. We have a data stream of RGB numbers, we can see 3 bits RGB, this is data for the first LED, this is data for the second LED, this is data for the third LED. The first LED gets the data, it consumes the first 3 bytes, and then it just forwards the rest of the data forward without processing. So technically every LED does not know about others. It allows manufacturers to make different LEDs configuration. It can be a simple long LED strip or it can be a matrix. So let's now go to Python and see how it works in code. Okay, now we know the general idea about the addressable LEDs, and let's start with coding. First, as usual, let's import the required libraries. The protocol itself can be pretty complicated, but luckily for us there is a library that is doing all job. It's called Raspberry Pi WS2812, as we can see. As I explained earlier, this library is designed for LED strip, but I bought an LED matrix. Technically it's just an LED strip used in this form. Obviously the tricky part here is to convert the coordinates, because we need to convert x and y coordinates to the linear index. First I will create an LED matrix class. Our connection diagram is simple. I am using this pin on the Raspberry Pi. This class will work as a wrapper, so inside it will have this pixel strip object. And the most important part of this class is this method coordinates to pose. As we can see, the logic here is simple. Normally we just multiply the x coordinate to the size of the matrix, but because we have this S shape, if the x coordinate is an even number, then it should be reversed. I will also create a method setPixel that we will use, and two other methods are just wrappers to begin communicating with the matrix and to show the values. Technically that's it. Let's test this library. I am drawing a white pixel in the 0 position, and I will draw a red pixel in the x-axis, and I will draw green pixel in the y-axis. We have RGB like this, so this pixel will be white, this pixel will be red, and this pixel will be green. Before we run the code, let me explain a bit about the connection diagram. This LED matrix requires 5-volt power supply, and here we have two options. The most simple option is to connect the LED matrix to the Raspberry Pi, but the challenge is that the Raspberry Pi power supply can be not powerful enough to turn on all LEDs. So in this case we will connect only input and ground to the Raspberry Pi, and the power must be provided separately. But for the code in this tutorial it is not required. I am not turning on all LEDs, so we are safe and it works well. But we must be aware that if we want to turn all LEDs on, the power from the Raspberry Pi may be not enough. Now let's see how it works. I will enable the terminal and we can run our code. And indeed we can see the bright red and green colors. So it works. Okay, now our LED matrix works, and let's do more fun stuff. Let's create a scrollable text. I will remove this main for now. I will create an LED text class. To draw the text we need a font and we need a font size. To draw the text I will use a pillow library because we need to draw the text as a raster, so we need to convert text to image. First I will create the method text to image, and as we can see I am using this pillow library. First I get the size of the text and then I draw it on the image. Our text will be scrollable, so I added a variable that will store our position of the scroll. As a second method I will create a function setImage to LEDs. As we can see its logic is simple. First I get the pixel from the image and I set this pixel to our LED matrix. Last but not least, I need to enable scroll position, so I'm increasing the coordinates, and if the coordinates reach the maximum, I reset it back to 0. The last method will be run forever, and within this loop we send image to LEDs and we update the scroll position. Technically that's it. It is enough to show the image. Now we can put the main code back and let's see how it works. I will enable the terminal again and let's run the code. As we can see it works and the image is pretty bright. As a fun approach, let's add a gradient. It is easy fix. We only need to update the method setImage to LEDs. Before I created a useGradient variable. If the pixel of the image is not black, I am using a Python method to convert the color. This should look much better. Let's run it again. Indeed, as we can see, now we have bright rainbow colors. It works. Okay, now the text scrolling works well. This approach often used in vending machines, in transport, in information panels. But now let's do more fun stuff. Let's make a small game and let's code Python in Python. I will create a small snake object that will move on our LED matrix and let's see how it works. First I will add two data classes for pixel and direction, and now I will create an LED snake object. As we can see, our snake has a list of pixels, list of colors, and a direction in which the head is moving. Then I will make a method createSnake. As we can see, it creates this list that was described before. Just for fun, I will set 0 pixel to a different color so we will see where the head is. Our snake has a direction as an angle, so I created a simple lookup table to get the position for x and y. As a next step we need to update collisions, because our snake can hit the wall. And I created this method, update collisions. It's pretty long, but the logic is simple. I get the coordinates of the head, and for example, if the x position is 0, then I need to update the direction. Let's say this cursor is a snake, and if it hits the left corner, I need to change the angle from 0 to 180. As a next method, I will create the random walk class. As its name suggests, it's update direction randomly. Viewers who wish can use buttons on the Raspberry Pi. In the previous video I explained how to use button, but just for simplicity I will update the angle randomly. As a next step I will create two methods to update the snake body. As we can see, I get the head position and I move this head position to a new coordinates, and then I just remove the tail, so the length of the snake is the same. Some people may remember the old snake game on Nokia phones where the snake was growing. Viewers who wish can update this method here if they want. Our code is almost ready. I will create a draw method. The color can be taken from the object or it can be default color. I will use it to remove the snake. And now I will create the method run forever that will implement all this logic. As we can see, I create the snake, then I draw the old snake with a black color so it will be not visible anymore. Then I update direction, then I update collisions, then I move the snake body, and then I draw a new object. And technically that's it. I will add a new main code. Let's see how it works. And as we can see, the snake is moving, the code works. It's much easier to see the direction because I set the head to a different color. Okay, that's it for this video. As we can see, the code works. We were able to test LED panel in different modes, in a simple pixel mode, in a scrollable text, and in a snake game. Viewers who wish can add buttons to the Raspberry Pi and make the game interactive. In the previous video I explained how to use buttons on the Raspberry Pi, so feel free to watch it again. If you enjoyed this video, press like and subscribe to see more content. In the next video, I will connect a fast API web server to this LED panel and we will be able to use it interactively. Stay tuned and see you next time. Thanks for watching.